Students, have you ever thought why uranium-238 is not decay in a single step, why a lot of people are concerned about atomic or nuclear war? Uranium undergoes in a decay process without any external source because it is unstable enough to do so, but it is not unstable to the extent that it can explode in a single step. It decays by emitting alpha or beta particles, which is a slow process. But another isotope, uranium-235, undergoes rapid decay with the release of extreme energy. This happens because initially uranium-235 is in a metastable state in which a slight disturbance by external source initiates the decay process. Due to this external influence, the radioactivity is called artificial radioactivity. But in this type of radioactivity, decay happens within no time because it splits uranium-235 into two lighter nuclei with emission of 3 neutrons and a great amount of energy. The splitting of uranium-235 in artificial radioactivity is called nuclear fission. Comparison of both types of radioactivities is shown in the table. Now, understand what nuclear fission is. Nuclear fission is splitting of unstable nucleus into two lighter nuclei with 3 neutrons and a huge amount of energy. It can be visualized in figure. As this fission happens due to external sources like neutron bombardment, so it is a typical example of artificial radioactivity. In uranium-235, you can see that a neutron interacts with uranium and in result we have krypton and barium plus 3 neutrons and a lot of energy as products of nuclear fission. The initial neutron is get through labs or reactors. Only initially, labs-produced neutron is needed to initiate nuclear fission. After that, more neutrons emits from nucleus which interact with other atoms of radioactive element and continues this fission process, till they completely decayed. The reason behind the release of a lot of energy compared to other decay processes is that during nuclear fission, the mass of reactants is always greater than the mass of products. This missing or loss mass is called mass defect. By using the Einstein's mass-energy equation, this little mass multiplies with the speed of light, whose value is very high, which gives a lot of energy with this little mass defect. Along this energy, 3 neutrons also emitted, which interact with other atoms of unstable radioactive element and causes more fission. The resultant neutrons from second stage repeat process with interaction to other atoms again and process continue like a chain. That's why fission is also called fission chain reaction. Due to this, the amount of energy released is so high that if not controlled or handled, it causes huge destruction. If this type of reaction initiated without any precaution initially, then it is impossible to stop it once it initiates. Based on this, there are 2 types of fission chain reaction, one is controlled and second is uncontrolled. In diagram you can see a neutron interacts with uranium-235 and a fission reaction initiated. In fission, along with 2 daughters nuclei, 3 neutrons are emitted, 2 of them are controlled by rods, made up of cadmium and only 1 is allowed for further fission. The process continues in arranged and control setup, until all atoms decayed. So a chain of control fission reaction formed, that's why it named as control fission chain reaction. We use this setup to utilize energy released during reaction by controlling reaction through rods so that release of energy remains within the limit. This reaction takes place in different stages. In the first stage, we use an external neutron to start the reaction. After that, every fission occurs with the neutrons emitted previously until the whole of the atoms decayed. On the other hand, if we do not use neutron-absorbing rods, then after first stage 3 emitted neutrons interact with 3 unstable uranium atoms, which on further fission in second stage interact with 9 uranium atoms, and process increases exponentially, which releases immense amount of energy, which cannot be controlled. If this type of reaction initiated, then it is impossible to stop it. That is what happened inside the nuclear bomb, where uncontrolled fission reactions take place, and within seconds, thousands of uranium atoms decayed and ton of energy releases, whose destruction had been observed in Hiroshima and Nagasaki. So that's why nuclear war is one of big concerns worldwide. Although nuclear energy is beneficial, but a little mistake can destroy the whole world.